So today we're going to talk about equipment data, and it's becoming the other tool your craftsmen need in the field. Was asked to give this presentation because I spend a significant amount of my time working with our clients in the field, helping them to develop their maintenance and reliability programs. Also recently I've been working with a client at an oil refinery in Louisiana, and they're undergoing a transition, actually an upgrade of their EAM systems. And they brought us in to take a look at some of their data issues and help them improve on some of their data practices. And I became interested in giving this presentation because I saw it as an opportunity to share not only what we're seeing broadly across the industry, but also what I've observed locally at this facility. So pulled together a quick agenda. We've got about 45 minutes, as I understand it, to give the presentation. And of course, at the end, there will be time to take some answers, as well as I'll leave my personal contact information for anybody that wants to get a hold of me after the presentation. But our agenda today is we're really going to talk about technology developments in the field and what we're seeing. We're going to talk about the importance of the data in reliability and maintenance work processes and how they relate to the technology developments we're seeing. We'll talk about the critical data elements that you should have within your systems. And probably one of the key points we want to stress as we go through the presentation is the need for data maintenance. Your data, the data in your system, is a living entity, but it also constitutes an asset, which that you cannot neglect if you want your maintenance processes and your maintenance systems to function properly. We'll talk about looking forward, meeting today's requirements, as well as some things we may be expecting in the future, and then at the end I'll briefly be able to take some questions and hopefully give some answers to anybody that calls in. Okay. So technology. It's no secret today that technology is changing the way we live, and particularly the way we work in the workplace. We have distributed control systems that are basically running and managing our plants. All of the data on our process performance, how our plants are running, are coming in remotely, allowing the operators of the equipment and those that are actually manufacturing the products we make to gauge their quality, their product performance, their machine performance in a very controlled environment. We're seeing that the equipment that we actually employ in the field is becoming smarter and more intelligent. As the power of computers, of central processing units has grown, so has the spread of technology from a central unit to a machine-based system where the machines that we're using in manufacturing and in our daily lives are becoming smarter, more intelligent. They're able to talk to each other, they're able to talk to us, and as technology continues to develop, they're becoming able to actually report on their health and declare when they're going to be in need of maintenance. All of this, of course, involves people. The execution of reliability and maintenance programs and processes is highly people dependent. And today what we're seeing is that mobile solutions, the use of iPads, of mobile computers, of tablets, of smartphones, is becoming integral to our capability to manage and deliver maintenance in the field. And they're becoming an integral tool to our craftsmen and technicians to do their work. And it's not just the craftsmen and technicians, but it's our engineers, it's our warehouse management people, our accountants. Everybody within our facility may not necessarily be tied to a desk today, but can actually take their technologies and move out into the field to collect data more hands-on, to actually observe what the information, what the data is telling us. Okay. Rona, what I'm interested in as feedback from the audience is to try to get a feel as to how many people have begun to actually explore these technologies so I can kind of guide this discussion. So if you would, we've got our first prompt poll. Could you display that for us, please?
Sure. So I'm going to go ahead and launch a poll, and as Bob mentioned, you can just type your answers right into your keyboard. You don't need to use the question feature. Just go ahead and type your answers. So Bob is asking, has your organization considered utilizing a mobile application for maintenance? You can answer A, we have not considered it. B, we've reviewed it and decided against using this technology. C, we have an initiative underway to implement a mobile app. Or D, we're currently using a mobile app. And again, just type your answers into the keyboard. And as soon as everyone has voted, it looks like about 2/3 have voted. We'll share the results. And again, as Bob mentioned, he is going to be staying around at the conclusion of the presentation to answer questions, but feel free to type your questions into the question box at any point during the presentation. So please feel free to do that. Okay, it looks like we have just about everybody vote. Oh, a couple more. All right, let me go and share the results with everyone. So it looks like, as far as has your organization considered utilizing a mobile application for maintenance, 51%, just over half, said really haven't considered it. 8% have said B, they've decided against this technology. 29% say there is an initiative underway, and 12% say they're currently using it. So it looks like, Bob, if my math is right, about 41% either are currently using it or have an initiative underway.
Okay.
Just over half have not yet considered it, and then 8% have reviewed and decided against it.
Okay.
All right, back to you.
All right, thank you, Rona. So what we need to keep in mind when people talk about maintenance is that when we think of reliability and maintenance, most people, what comes to mind for most people is the work that our craft people are actually performing in the field. It's the use of tools, the use of wrenches, the use of electrical calibration equipment, vibration analysis, thermography, the use of tools and the performance of work in the field, the hands-on stuff. But when you look at what does it take to really deliver reliability and maintenance, it's not that at all. The delivery of reliability and maintenance is very highly dependent today on the identification of your work and the gathering of the information that you need for the craftsman to do the work. That's the major part of your reliability system. So if we study and look at the business process where we actually use to identify work, approve work, plan, schedule, and execute work before instructions, before the work ever reaches the hands of a craftsman, it's a very long chain. And it all involves the compilation and the delivery of data on the system. We have to be able to identify what the equipment is we're going to work on. We have to decide, are we going to spend the money to make the repair? And who's going to do the repair? Is it going to be done by internal resources or external resources? From that, we have to plan the work. And this is where the real heart of the data that we need in our system comes into focus, is we need to be able to identify, to properly plan work. We have to identify the parts, tools, materials, and knowledge that a craftsman needs to be able to properly execute his work. From there, if we need materials, either internal from our storeroom or external from an equipment supplier or vendor, we have to be able to purchase that material. Again, our CMMS or EAM systems are designed to allow us to make those transactions. From that, We work with our production people to actually schedule the work. Again, that's another data transfer within our system to determine and work with production to find out what is the length of time that it's required to perform work, and then within our production schedule, what's the availability of the equipment to actually perform the work. In work execution, when a craftsman goes to perform the work, he needs to know what it is he's supposed to do. He needs to have the right parts, tools, materials, and knowledge to properly and safely perform the work. If he doesn't have those things, what is he left to do? A craftsman, with a work order that hasn't been properly planned, that hasn't identified everything he needs to do the job, is basically left up to create it for himself on the fly. And there's ample data within industry to show that that's a very, very expensive proposition for most industries. A craftsman can spend a considerable amount of time finding those things he needs to perform his work. And it can be further complicated for him if the data that he needs to even perform the work at the most basic level is not contained within our EAM or CMMS system. And of course, to close out the process, we have to be able to complete the work and gather the data on what was actually done in order to analyze and review that work so that we can improve our maintenance and delivery process, hopefully optimize our reliability program, reduce our spending, and improve the performance of our plant. All of those things have a tremendous business impact on the performance of our plant and the profitability of our business. But none of that happens, or it doesn't happen very well, if we don't have the proper data contained within our CMMS or EAM system. Okay? So without accurate data in our CMMS or EAM system, the system simply won't function properly. When a planner goes to plan a job, if he can't find the right equipment, if he can't locate the spare parts or materials, if he can't identify the craftsmen and the craft codes that are required to perform the work because there's a gap or a lack of data in the EAM or CMMS system, the system simply breaks down. And it, again, going back to our previous slide, what this really represents is like a railroad. It's a chain of data, a chain of events that has to follow consecutively from one step to the next. To highlight this, the data within our system should be viewed as an asset, the same as any part, tool, or piece of equipment that we have in our plant. It has substantial value, and it plays a functional role in helping us perform our work, the same as any piece of performance equipment. The other thing to keep in mind is that to create the data in a CMMS or EAM system, we typically have to invest substantial numbers of man-hours into creating that data, and that represents an investment that you should maintain. The other thing we have to keep in mind is that once we begin to use the data in our system, it's a living document, and it's subject to change at each step along the way in our process. People routinely change the spare parts and materials they use. They routinely revise the craftsmen they're going to assign to work or work performance. They routinely revise or modify the equipment in the field. We have to have some way to capture on a daily basis the changes that are taking place not only in the physical world, but within the data in our system so that it continues to support us properly. If we do not have a way to capture those subtle changes, over time they become cumulative. And if enough deviations and enough variance occurs within the data of our system, it will reach a point where it will almost become unusable, and it will fail to support us properly. Okay? Again, we can see the business results of the use of the data. Having a well-functioning CMMS EAM system allows us to continuously improve how we're performing our maintenance. It allows us to identify our equipment, cover more of it with bills of material, eventually allowing us to reduce the spare parts that we have in storage in our warehouse. It allows us to identify what equipment is failing and how, which will allow us to improve both the predictive and preventive maintenance we're doing in our system. And when we study the overall business results, again, the business results are rather dramatic. People who have well-developed reliability and maintenance programs that are in the first quartile of performance typically have a maintenance spending per replacement asset value of 2.5% versus 5% in the second quartile, and even higher in the third and fourth quartile. That represents nearly a 50% reduction overall in what you're spending in maintenance and spare parts and material for your program. So the cost savings and the benefits are quite large in most instances. Okay? Critical data elements. What are the things within our system that we need to make sure we have in place and that are well maintained? The first is we need to be able to identify our equipment asset data. We need to have good records on all of the assets that are within our facility. Whether it's a pump, whether it's a motor, whether it's a piece of switch gear, a blower, a fan, a compressor, we need to be able to identify that piece of equipment and collect the attribute data for that, so that when a planner, a scheduler, or a craftsman looks in the system, he can identify that piece of equipment, understand what it is, and be able to make decisions about how it should be repaired or how it should be maintained. We have to be able to identify within our system the hierarchy, where the equipment is in respect to the plant, so that we can simply locate it. Most EAM or CMMS systems today, we ask the people in the field, the people in the plant, the operators, the engineers, the technicians, the lab and QC people, to put in work orders or work requests that will allow us to repair or maintain the equipment. It's critical to our system to be able to identify that equipment, what it is and where it is. We also need to have a well-defined criticality ranking for each piece of equipment, so that we can identify what is the critical nature of this equipment, how important is it in relation to our business, so that we can distribute and allocate maintenance resources and plan and schedule our work accordingly. Within our EAM system, we need to have well-defined both predictive and preventive maintenance plans, processes, and procedures. Now, the EAM systems have grown dramatically in the last few years, and their capability to gather this data, organize it, and allow us to assign the proper predictive, preventive maintenance to any type or any piece of equipment. But it takes resources to sit down, go through the equipment, look at the hierarchy, look at the criticality ranking, and decide what predictive and what preventive maintenance should we be applying. We also need well-defined bills of material that help us identify, again, what are the spare parts and materials we need either in our storeroom or locally available from our vendors to support the equipment. Over time, we need, within our EAM system, the equipment history. As we perform work in the field, we want to gather what predictive and preventive maintenance was performed on the equipment, how it was performed, what problems or what repairs did we need to take and make on that equipment to create corrective We also need to be able to look at what changes or modifications we need to make to our EAM system so that we can optimize our maintenance and reliability program. Certainly we need to be able to track our budget and cost, how much time, resources, and man-hours are we spending. And then within an EAM or CMMS systems today, we can link repositories of equipment documentation, the manuals, the drawings, the procedures, all of the documentation we get from our equipment suppliers can now be stored within a database and linked to our EAM system so that it's readily available to our planners, our schedulers, and our craftsmen when they go to work on the equipment. Okay? So how does all this roll up? As I said early in the program, I was recently working at an oil refinery in Louisiana, and the work assignment we had is helping them revise some of their equipment data in order to prepare for the transition and an upgrade to their EAM system. And working there, we got to know some of the people working in the facility quite well, and I got to know one of their planners named Jeff. One afternoon, I was taking a break and ran into Jeff in the break room, and he was quite dejected. The plant was in the middle of a startup, and one of the equipment repairs that he had planned for was for the replacement of a coupling on a very large pump and motor system. And again, this was during a turnaround situation. The piece of equipment was critical, and Jeff had planned the job. And when he planned the job, he had utilized the spare parts, the equipment history, and the materials information that was contained within his EAM system. He had, in fact, gone out and looked at the job, but because the equipment was in operation, he was not able to tell a significant amount about it, and what was required was the replacement of the coupling on the pump. So he could not actually check to see the coupling. He looked at the equipment information in the system and bought what he understood was the proper coupling. Unfortunately, what had transpired was several years earlier, the electrical group had to replace the motor that drove the pump. When they replaced the motor, they had changed the frame size, and as a result, they had changed the coupling. It was unfortunate that the information of this change and the new coupling requirements for this pump and motor combination, the data for that had not been changed or re-entered into the EAM system. And as a result, when they went to perform the job, they didn't have the proper coupling to execute the work. It took about a day and a half for them to obtain the proper coupling and actually install it. And it created a significant amount of extra downtime within the refinery. And this one instance alone would probably have cost justified an entire revision to their asset database. It was in upwards of over $1 million. Okay? As I was preparing for this presentation, people were asking me, Bob, what constitutes good data versus bad data in the system? And of course, we've touched on a very broad range of asset and equipment data that is required to have a functioning EAM or CMMS system. So from this perspective, it could be almost anything or and generally a lack of data within your system. So what I would suggest is you begin to look at the data within your EAM system. You want to pay attention to not only what may be inaccurate data, but where are the holes? Where are the gaps within your CMMS system? Where are you missing equipment attribute data? Where are you missing bills of material assigned to specific assets? Where are you missing predictive, preventive maintenance work orders assigned to assets as well? Okay? And building on that, you should actually have an asset data maintenance plan for your EAM system. For most of us, that's going to require, well, first off, a dedication of resources. You've got to have somebody within your organization that understands the data requirements of your EAM system, and we've got to dedicate a resource to begin to analyze that data. We want to create plans and procedures for that audit. And typically you want to do quarterly and certainly no less than yearly audits on the data within your EAM system to determine, is it being properly maintained? Are your planners, your schedulers, your craftsmen, your engineers putting into the system the proper data in the proper format, and are they, when they have changes in the field, are we capturing those? Once we've identified where issues are occurring within the EAM or CMMS data, we also need to have in place a tracking system to look for resolutions. Are the problems with our data the fact that the data within the system was never properly entered, never properly completed? Or are we having trouble with our personnel entering the proper data at the completion of their work? Why is that? What are the obstacles for them to complete this work? And what training or what changes to our system do we need to make that will allow them to do that? Okay? And certainly, and last but not least, is we need to have a management of change process actively employed within the plant. Because, oh, by the way, it's not just the maintenance and reliability department that is changing how our equipment performs. Typically, I've found the operations and the quality departments are making changes to how they operate the equipment, such as the length of time they operate the equipment, the process parameters that they operate the equipment under, that can significantly impact the maintenance that is required as well. And all of that should be being captured with a management of change procedure. Okay? We talked at the beginning about the application of data and the application of technologies. And if you follow Moore's Law, which has not changed, I pulled this graph from Wikipedia, which clearly demonstrates that Moore's Law has not changed in the last 4 decades. And what Moore's Law means is that the power of our computer processors, of our memory systems, of the computing power of equipment is only going to continue to increase over time. I don't believe there's any end in sight as to where this is going to go. And all we can do today is prepare for the future. Okay? And so to prepare for today, what that really means is that to take advantage of the technologies that are becoming available to us, we're going to have to prepare to collect and gather and input more data into our systems to make them capable of supporting us in the way they desire. When we look at reasons why most people are dissatisfied with the performance of their EAM or CMMS systems, what we find is that it actually has nothing to do with the software and everything to do with the quality of the data in the system or how people are trying to employ the software systems themselves. If we plan to utilize greater technologies in the future, we must prepare ourselves to gather and input the data that's actually required to make those systems function. And it's unfortunate, but it's absolutely true that there's no one that can do this for you. It has to be done at the local level by either the people working in the facility themselves or a team of experts from outside that can come in, collect this data, develop these programs, and input it into a functioning system. Okay? Once the data, again, is compiled, it has to be maintained. It's a living document. And one of the best ways to accomplish this is to actually have our craftsmen, the planners, the schedulers, all of the end users actively engaged in maintaining the data process, which means we have to train them not only in how to input the data, but why they need to input the data and its impact if we don't do it properly as well. Okay? Well, what I'd like to do now is ask, we had another prompt question to determine how many people today actually have data management programs in place and data. Can you bring that up?
Sure. So Bob has asked me to launch another poll, and we'd like you to type your responses right into the keyboard and let us know A, B, or C. Do you have written plans, processes, and procedures in place to maintain asset data? And I think what Bob is saying, your asset data is a critical asset of itself, and does it have work plans, processes, and procedures in place for the ongoing maintenance of it? So let us know, A, you have committed resources with written plans and processes. B, the data is reviewed, but there really are no written plans and processes. Or C, no formal effort exists today. All right, looks like about 2/3 of the votes are in. And again, if you can type your responses in, we're about 80% there, so we'll leave it up for a few more seconds. Let us know A, B, and C of where you are as far as having written plans and processes and procedures for maintaining this data. Okay, let me share the results now. And Bob, what our audience has said, 28% have said resources are committed and there are written plans. 36%, little over a third, says the data is reviewed, no written plans are in place. And another 36% say there really is no formal effort today or written plans or procedures.
Okay.
All right, back to you, Bob.
Okay, Rona, thank you. And I think that's very valuable data for everyone because what I'm hearing is that roughly 2/3 of this audience, which should represent a very good statistical sample, really don't have a solid data management, data maintenance program in place. And so my fear is within industry in general, as the demand for the use of technology, for the demand of this data is only going to grow, and that there is a huge need to improve on how we're actually managing, how we're actually maintaining our data going forward. Okay? Rona, what I'd like to do is open the floor up to questions. Do we have any?
Sure, okay. So what Bob is asking, if you want to go ahead and type your questions into the question box, and I will read them to Bob as we still have a few more minutes until the top of the hour. And one of the questions that came in, Bob, is some people were asking, you showed a slide that showed maintenance spend and RAV, I think that was return on asset value, and where people were that were in the top quartile versus others. Can you please just explain that formula for our listeners?
Yes, I can. So when we look at this formula, and it is a very common measure of your reliability and maintenance program is to assess how much you're spending on reliability and maintenance in relation to what is the replacement asset value of your facility. So if my facility is worth $100 million to construct as a greenfield site, and I'm spending $10 million per year to maintain that, so my replacement asset value would be 10%, and so I would have to rank the performance of my reliability and maintenance program in near the bottom, certainly of the third quartile, but actually in the fourth quartile in terms of its performance. So it's a simple ratio, but you want to capture what you're spending for reliability and maintenance to make sure that your equipment performs as expected, and compare that to the greenfield cost of your facility. Okay.
Great, that's helpful. And then another listener who said they're in the transportation industry.
That's correct.
And does the RAV formula translate to vehicles as well as equipment if you're in transportation?
Yes, it does. You know, a vehicle is the same as any stationary performance piece of equipment. It's a machine. It has wear parts. It has maintenance requirements. And if you assess what the cost of the piece of rolling stock, whatever that is, and compare that to what you're spending on maintenance, there should be a well-defined ratio. Of course, now I have experience, Rona, in mining and some other industries where the rolling stock and the equipment is subjected to significant abuse and wear, and so you also have to take into account when you do those calculations what industry you're in. But again, the benchmark is a solid gauge for where you are. It generally applies across all industries, and there is some variation, but in my experience, it's not significant.
Great. Okay. Thanks for clarifying that. And another listener asked, is wrench time still a critical maintenance measurement in your view?
Yes, it is. Of course, what we're trying to do with reliability and maintenance programs is by doing better work planning and scheduling, that's at the heart of how to increase wrench time in the field. And what we find is that for maintenance programs that we rank as reactive, and typically they fall into the third and fourth quartile, where there are not dedicated resources for maintenance planning and scheduling, where work orders are simply issued to craftsmen. What we find is that the craftsmen spend a considerable part of their time to hunting down and finding the parts, tools, materials, and knowledge they actually need to perform their work. And so when you do wrench time studies, you know, a good number for wrench time in a reactive environment may be 20 to 30% of a craftsman's time is spent working on the equipment. The balance is actually spent just trying to prepare to do the work he's been asked to do. With proper maintenance planning and scheduling, you can drive up that number considerably, up into the mid to high 60s. And therefore, when you look at wrench time, it's actually another good measure of how well your maintenance program is behaving overall, and it's also a good measure not on how hard your craftsmen are working, but on how well they're being prepared to do the work, on how effective your planning and scheduling is. Actually, Rona, and having worked in environments that are highly reactive personally, what I typically find is that people working in those environments are working very, very hard in relation to their peers. People working in highly proactive environments where they have solid predictive and preventive maintenance programs, they're doing a different kind of work. They're utilizing technologies, whether it's vibration analysis, thermography, ultrasonics, or motor circuit analysis to actually gauge the health of their equipment and then take proactive action to keep it from failing. And when you do a calculation of wrench time, you need to take that into account, is that doing predictive maintenance is actually should actually be considered a use of wrench time as well. So it's a completely different way of approaching your work. But you know, the other analogy I like to use is in a proactive environment. The people that run the ambulance service, the emergency medical technicians who hurry to an accident, work very, very hard. But when you go to your physician for an annual checkup, he's working no less hard, but he's working just in a different manner. At the end of the day, for your business, what would you prefer? To wait until your equipment fails and you have to call in the EMTs, or you proactively go to a doctor, you get a medical checkup, and he prescribes a diet and exercise and perhaps prescription routines that keep you healthy and keep you from failing. Okay?
That's very helpful. Gosh, we've had a lot more questions come in. I'll try to get through as many as I can. One listener is asking, what elements, Bob, when you're including on the screen the cost, what elements do you typically include in your annual maintenance cost? Can you just give the listeners a good rule of thumb or a checklist of which costs they should be including?
Sure. I'll be glad to, Rona. So typically your maintenance costs are your labor, okay? To work on the equipment. That should also include you know, your maintenance staff as well, the supervisors, the planners, the schedulers, engineers, etc. So at the end of the day, all of those costs should be collected. Certainly any cost for parts, tools, materials. The cost for developing your data, for actually collecting and entering data, should be entered as a maintenance cost. And then any contract work you're performing by outside contractors to come in and service your equipment should be captured as maintenance costs.
Great. Well, that I think leads us to another question from another listener that said, how much time and money would you typically spend on a weekly basis to maintain good data? So if you've inspired some of these folks here today, Bob, to want to undertake this, you know, what type of time commitment or you know, might someone anticipate to really invest in the quality of their data?
You know, Rona, that is a very, very difficult question to answer because it's highly dependent on the size of the organization. It's going to depend on the current state of the data within the system, how well it's developed, and the changes that are occurring within the field. But I will say this: typically, when a craftsman completes a job, you should allocate time in the work plan for him to complete the work order and enter the data into the system on what corrective action he took, what parts and material he used, what changes he made within the system. You know, depending on the size and the complexity of the task, that can vary, but you know, typically 15 to 20 minutes for very simple jobs, longer if they're more complex. When you plan and schedule your maintenance work, you want to be sure you allocate time for people to do that. When you have maintenance planners and schedulers, that's an active part of their job, and I've never run into anybody that tried to actively separate that task from the other work they're doing, as it is an integral part.
Yeah.
But,
I do know, Bob, we had some listeners, as you were saying, about, data being an asset and requiring really a plan and procedures. I've heard clients similarly say that they've, in our system, and I'm sure people out there maybe have done this in other systems, other CMMSs, they'll actually set up as an asset, let's say, their safety minutes or their procedures for that, so they have a permanent record. And perhaps, even defining your data procedures almost like an asset, so it'll trigger, tasks to you to remind you to do the updates is something you can do with
Rona, that is certainly an approach you can use, and thank you for that.
Someone is asking, you've referenced EAM and CMMS, and so many of us use them almost interchangeably. And Bob, can you just shed a little light on what you see as when you refer to CMMS versus, EAM? What do you see as major differences? We try to say our systems are both, but what are the major differences you're referring to?
Sometimes those differences are somewhat subtle, but largely a CMMS is a computerized maintenance management system, and typically, Rona, those have not been integrated with the general ledger, the other software within the business maintenance or business management systems. An EAM system is typically a large package that is linked and is an integral part of the other business software within a system. It's an EAM is an enterprise asset management system. So typically you see it's integral to your general ledger, to your purchasing, to your stores maintenance, to your personnel, records and documentation, and other systems that allow you to manage your business.
Gotcha. And some people have been asking, Bob, if you'll be making copies of your slides available today if they want to take this data and refer back to it or share it with their teams.
Yeah, Rona, we certainly can, and I believe you've recorded this presentation and you're going to store it on the email system as well. Is that correct?
Yes, we will be sharing the recording if people, again, want to watch it, and we'll share the link with all our listeners. But if they'd like to get a copy of the PDF, do you maybe want to also put your contact info, Bob, in case some people do want to follow up from you?
I certainly
will.
Some
people also have interest in following up with you and seeing if you'll do one-on-one seminars. And what I will do, folks, is I'll share the contact info with Bob, any questions specifically for him, so that he can reach out to you directly on that. If we have time, Bob, are you still game for a couple more questions?
Yeah, I've got until the top of the hour, Rona, and I'll be glad to answer any questions as best I can.
The other, when you were talking about RAV, which I think, if you want to again see what that formula stands for, and can you specify what stores value? That was the blue on that same graph?
That's
there
correct.
was the return on asset value, and then there was also stores value. Can you just clarify what stores value is?
The stores value is simply the inventory value of the spare parts, tools, and materials that are contained in your storeroom that are dedicated to maintenance. By the way, most storerooms within a production facility also handle operating supplies as well. Those should not be included as part of that calculation. But typically, it's your spare parts, tools, and materials that are stored in your storeroom. You also want to be sure to include if you have remote storage locations or in some facilities where people are storing high-value parts and materials in lockers, under desks, or in locations outside of the storeroom, we want to make sure we capture those costs as well because they all add together. Okay.
Great. Okay, well, that's good to know. Well, I think if I'm going through that are most of the questions that we have. And again, I would like to thank Bob and everybody else who's on the line with us today for participating, and particularly thank you, Bob, for putting this together and sharing it with our audience. And at the conclusion of this session, there will be a brief survey, and we'd really appreciate your feedback, and also let Bob know if you would like to get a copy of his presentation. That's the way that you can do so. And I encourage you to give us feedback on these sessions, because our goal is to make them as helpful and provide you with content that is important to you. So thanks again, Bob, for putting this together, and I hope we can do another session real soon.
Yes, we can, Rona. And again, I want to thank everybody for their attendance and their participation, and for the feedback they gave us on the prompt questions. And I want to encourage anyone that has a need to contact me to reach out, and I'll share almost anything I can with them. Okay. I'm trying to get that last slide up. Please forgive me.
No problem.
All right. Yeah. So there's my contact information.